Assalamualaikum warahmatullahi wabarakatuh to everybody's watching, everyone, and also to my lecturer that will be evaluating me through this presentation, Dr. Halim. My name is Yang Maizurah Zafirah binti Mohd Hishamuddin, student of Petroleum Geoscience, and today I'll be presenting a technical paper review regarding FK filtering. So the title of the technical paper review for FK filtering that I've chosen for today's presentation is combining FK filter with minimum entropy slot migration algorithm for subsurface object imaging and background permeability estimation. Overview of my presentation today. So I will start with the objective from the paper. So the objective that I've seen is summarized from the paper itself. First of all, is removing the direct wave using FK filtering. Second, analyzing the combination FK filtering and salt migration algorithm for subsurface object imaging. Then to improve the focus effect of the radar image and realize the precise inversion of the background relative permeability. So the purpose of this introduction is to intro the purpose and of this experiment done by the researchers. So this is a summary of it. First of all, ground penetrating radar is a GPR technology help detecting and localizing subsurface objects due to advantage of high resolution and fast profiling. So it is a widely used aspect or technology, widely used technology nowadays, where it used for highway construction, building construction, survey of shallow subsurface geology and geological exploration. Okay. Based on the introduction, migration methods were implemented to achieve subsurface data, but the imaging resolution is seriously affected by the direct wave. So in here, direct wave is the noise that created from the GPR. So several techniques have been implemented to counter this noise or this problem, such as background subtraction and window filter. But while doing the experiment, the targeted was too close to the ground, and the direct wave and the targeted echo almost reached the receiver, but didn't reach it. So that end up becoming unvalid. So some of the method that they use to encounter this problem is by implying the FK filtering method, where FK filtering method will help by separating the reflection wave that arrive from different direction and position. But by not using just FK filtering, they also use other methods that combine with FK filtering to help enhance the data itself, as shown here, sorted migration algorithm and underground dielectric and EM propagation. So from the introduction itself, we can know what the problem statement is here, is where the imaging resolution is highly damaged and severely affected by the direct wave. Second, the targeted is too close to the ground, causing it to be invalid, and the interference direct wave will greatly affect the accuracy and the resolution of the GPR imaging. Okay, now I'll be presenting the method and application. We're going to start off with the FK filtering method. So FK filter ring method that they use in this experiment is according to this FK filter theory, where frequency number is filtered in a filter is used to suppress interference wave based on the difference between a significant wave and interference wave, in a frequency number spectrum. So by using a 2D dimensional radar on the ground, the frequency spectrum is recorded as this equation. Ex Z equals to 0 T. Two-dimensional radar record on the ground is represented in this equation. Then use an FK filtering equation here. So what are the substance here? So HKW is the filtering function. GKW here is the filter spectrum. So by applying 2D inverse Fourier transform to this GK, we can obtain a spatial radar profile without the interference wave as shown here in this equation. So two-dimensional filter make use of different apparent velocity and frequency between a significant wave and interference wave to achieve a filtering which can be expressed in an FK plane. Okay. This is the FK plane. So let's see what's in the FK plane. Here, the apparent velocity can be expressed as VFK. V equals to Fk. The zone 1 here, zone 1, is the interference zone of high velocity. Zone 2 is the interference zone with low velocity. So the dipping angle in time-space domain is greater. The line in the frequency wave number domain is closer to the wave number axis. So the spectrum component with a zero dipping is on the frequency's axis. Then the zero dip is equivalent to the zero number. It is shown here through the researcher, through the paper that I've read, that the direct wave arrived at the same time. Apparently, there is apparent to the velocity and infinitely large. As a result, the spectrum component of the direct wave of Fk dominant is distributed along the frequency axis. That is partial frequency k equals to 0. So according to the paper, the main noise here, according to this theory, the main noise here is the direct wave. So the filter is to be obtained and applied as Fk domain, as shown in the diagram here. Now I'll be presenting the second method, that is salt migration method. Salt migration method is actually takes on advantage of both Kirchhoff integral method and finite difference method, where the algorithm is based on wave equation migration that make use of the wave equation to backpropagate the record wave field in order to develop an image of the subsurface geological structure. So here's the equation used in this method, where x is a horizontal coordinate, t is the time along the depth direction, z is the depth coordinate, v is the velocity of migration, and k, x, x, k, z, k are the wave number vector in the horizontal and vertical component respectively. So the third method that they use, this is a combined method with the salt migration method that they use to combine for the FK filtering. So this technique is function to maximum is function to help solve migration equation and technique. So the maximum value of entropy is 1 for the single trace data set when the data is contained only peak pulse with a single unit amplitude. So the greater the entropy is, the more confusing the image target point is. So minimizing the entropy image after the migration process can optimize focal effect. So the effect of migration uh, process can be evaluated by a minimum entropy technique in order to make the focus even more effective and more optimal. So after explaining the method used in this research, um, the result and analysis of the data from the paper is shown here. Both of these images are, first of all, window filtered image. Second are salted immigration image, the one that is have been filtered with salted migration. So the direct wave is effectively removed, but when the targeted is too close to the ground, the direct wave and the targeted echoes almost reach the receiver, making it invalid. So you can see at the slot migration image of minimum entropy where it's become not so visible anymore because it's too close to the receiver, as first said to the paper. So now is the result where it has been combined with FK filtering. So I show it with a pointer. That's the point. Okay. Here, okay. Here, the FK spectrum of the forward profile, we can see that the direct wave spectrum and the targeted uh, refraction wave in the FK domain are separated. You can see they are separated. So, so because of this, you can see on this image and this image as well. The FK filtered image is a little confusing because the part of information of verticals on the target echoes are somehow the same with direct wave spectrum is also filtered, so it does not obviously affect the overall estimation radar image. So to make it more easier, here is a more clearer outcome from the experiment, the result. According to the result that shown pictures and the table, FK filtered image is also suitable for migration processing. We can tell that by the equation just now. And the strike velocity is even closer to the background propagation velocity. And the FK filter is more effective and automatic than the window filter, where the window filter we can literally see after um, applying the salted migration it's completely gone and it's unvalid. So without the active filtering we cannot produce such data as the previous slide. So as a conclusion, first of all I will start with the recommendation from the paper itself recommends that the FK filter is used for direct wave suppression. SNR improvement is to improve the GPR image. And then sorted migration algorithm is combined with the entropy technique is to enhance and help the FK filtering in separating the direct wave or any noise that will create from the GPR. So as a conclusion, this experiment result based on a simulated data, not real data, that the presented algorithm can achieve cooperative result produced by a window filter based on a sorted migration algorithm. Now we come to an end of this presentation. Thank you for hearing my presentation on technical paper review regarding combination of FK filtering method with the salt migration with minimum entropy method. So thank you.